Welcome to the Explainer. Today, we're diving deep into a completely critical, high-stakes AWS architecture concept. We're talking about break glass access. Look, if you manage cloud infrastructure, you know the drill. Our source material highlights this as the ultimate failsafe. It's the one thing you really hope you never have to use, but absolutely need to have ready to go. All right, picture this scenario. It is 2 a.m. You get a frantic phone call from a colleague. Your main payment service is failing, and customers are getting errors left and right. So you jump out of bed, grab your laptop, and you go to your AWS single sign-on portal to log in and fix it. But the portal just says, service unavailable. You try again. Same thing. Your identity provider is completely down. You're wide awake, you know exactly how to fix the production issue, but you are totally locked out of your own AWS accounts. So what do you do now? Okay, let's dive into this blueprint. Today we're going to cover the 2 a.m. nightmare, what break glass actually is, the 3-layer architecture, a step-by-step implementation, and finally, handling break glass emergencies. Section 1, the 2 a.m. nightmare, when normal access fails. So, during normal day 2 operations, access is temporary and centrally managed through something like IAM Identity Center, right? And that's great, it's highly secure. But it also creates a massive single point of failure. Just look at how many ways that normal flow can break down. If your identity provider, like Okta or Azure AD, goes down, bam, complete lockout from all accounts. If IAM Identity Center has an outage, nobody can assume roles. What if someone, say, accidentally misconfigures a service control policy on your root account? Suddenly, Identity Center fails to assume roles. Or even worse, what if your identity provider is compromised by an attacker? You have to cut off SSO immediately, which essentially means locking your own team out. How on earth do you respond to the incident then? Section 2. What is break glass? The emergency fire alarm. Think about the physical world for a second. When a building is on fire, you literally break a physical glass panel to pull the alarm. Well, in cloud architecture, we need a digital equivalent. Break glass is that pre-established emergency access mechanism. It intentionally bypasses your normal authentication and authorization flows for a very specific selected set of people during critical incidents. It has to always be functional, it needs to be simple enough to use when you're under extreme pressure, and must trigger immediate alerts, and it is strictly, and I mean absolutely strictly, for emergencies only. The contrast here is pretty stark, actually. And it shows exactly why these systems have to be separated. Day 2 operations are centralized via SSO, they have no stored passwords, and they rely entirely on temporary access. Break glass is the exact opposite. It entirely bypasses that normal centralized flow, it absolutely requires hardware multi-factor authentication, and it operates completely independently. They just have to be architecturally separate so that a failure in your daily operations doesn't end up taking down your emergency backup. Section 3. The 3-layer architecture, a production-grade solution. When we look at a dedicated break glass approach, which, by the way, is widely considered the most robust production-grade solution, the architecture relies on 3 independent layers of emergency access. Layer 1 is a dedicated break glass account, Layer 2 is the management account, and Layer 3 contains your critical member accounts. The absolute genius of this setup is that the break glass account is completely disconnected from your SSO, and it runs literally 0 workloads. It is a perfectly isolated island. Now, you might be wondering, why do we need break glass users in both the break glass account and the management account? Well, this breaks it down perfectly. If SSO is down and you just need to access your member accounts to fix a workload, the break glass account works like a charm. But if you need to fix AWS organizations, service control policies, or Identity Center itself, the break glass account fails. It just doesn't have those core permissions. For that, you really need the management account users. By having users in the management account, you avoid having to use the absolute last resort root user. And that means your recovery is faster and it's fully audited. Section 4. Step-by-step implementation, building the blueprint. All right, with the architectural theory out of the way, here is the exact 5-step deployment roadmap from our source material. Step 1, create the break glass account. Step 2, create the break glass users. Step 3, create the management users. Step 4, automate cross-account roles. And finally, Step 5, set up monitoring alerts. Let's actually break down exactly what each of these entails. Okay, step 1 is all about creating that dedicated, isolated account. You got to use a unique email address, something like AWS-breakglass@xyz.com, that isn't shared with any other account or group. Then place it safely in the security organizational unit. But most importantly, you need to ensure complete isolation, no SSO access, zero workloads running, and make sure absolutely no service control policies are blocking the STS assume role action. Otherwise, your emergency users simply won't be able to reach your production accounts to fix anything, which kind of defeats the whole purpose. Now, as we move into steps 2 and 3, which is creating the actual users, this quote is the golden rule you have to follow. Implement dual control. One person holds the password, another person holds the MFA device. Seriously, think of this like a nuclear submarine or a missile silo, where two keys have to be turned at the exact same time. It's a brilliant way to prevent any single person from having unilateral, unchecked access to your entire infrastructure. To securely configure those 4 Break Glass admin IAM users across your accounts, the guidelines are super strict. They insist on hardware MFA only, like a physical YubiKey. In fact, it's highly recommended to avoid phone-based authenticator apps altogether. Console access is enabled, sure, but those passwords, they should be stored in an external security vault completely outside of AWS. The physical hardware MFA keys themselves should be locked in a literal, physical safe in your office. And as we just mentioned, you want to split this access between 2 highly credible people, typically your cloud platform lead and your CTO. Moving on to step 4, the architecture requires deploying 2 specific roles into every critical member account. Break Glass read-only for investigating the outage, and Break Glass admin for when you actually need to go in and put out the fire. The huge takeaway here is to automate these cross-account roles rather than trying to create them manually. You can use tools like CloudFormation StackSets or Account Factory for Terraform to deploy them consistently everywhere. And just ensure these roles explicitly trust all 4 of the Break Glass users you just created. And finally, step 5. Our source material highlights this as an entirely non-negotiable step. High urgency alerts. You absolutely need to configure CloudTrail and EventBridge to trigger an immediate alert on a few very specific actions. We're talking any console login by a Break Glass user, any assume role call to the Break Glass roles, literally any root user login, or any failed login attempt on these accounts. If the glass is broken, security and PagerDuty need to be notified instantly. You have to know right that second if it's a real emergency or if an attacker just found your keys. Section 5. Break Glass emergencies, testing your safety net. Setting this infrastructure up is really only half the battle, because as any good engineer knows, an untested backup isn't a backup at all. It's just a wish. So to guarantee the fire alarm actually rings when you pull it, you need a strict 6-month drill checklist. First up, notify your security team that a drill is starting. Then retrieve the credentials from the vault, log in, and successfully switch roles into a non-production account. Once you're in, verify with security that the high urgency alerts actually fired. Then log out, return the credentials, and, this part is key, rotate the password used during the drill. Finally, document the results. You really should be doing this biannually. So I want to leave you with this final kind of provocative thought. If your identity provider went down right now, tonight, at 2 a.m., could your team actually access your AWS accounts to save production? If the answer is no, it is urgently time to start building your Break Glass architecture. Thanks for joining me on this explainer. Get out there, start building those safety nets, and I will see you next time.